So let's look at this example on the left, string literal, where we are working with strings and we have a program here. So let's say this is the memory that we have, and these are, let us assume, the memory blocks, different memory blocks in the memory, heap memory. And let's say this is address 100, this is address 101, 2, so on so forth, 110, so on so forth, 111, 120, so on so forth. So let us say at line 4 string a string equals to u. So this is created here. Let us say this string literal is stored here, u, and the reference for this is being pointed by a string, right? A string points to the string literal u at address 100. At line 5 string b string is equals to u plus u. So here, since we're adding two string literals yo plus u, so that gives us yo plus u, that gives us the complete string u. This happens at the compile time. So the compiler then stores this string, looks for this string in the heap memory. If this string literal already exists, it points to that same location. So this already exists, right? So then the compiler creates the reference b string pointing to the same string literal at address 100. It doesn't create a new one. At line 6 c string is equals to u. Since you already have a c string, so we already have a string literal u. So therefore c string also points to the same memory location, that is address 100, where u string literal is stored. Now at line 8, if c string equals to a string, equals to compares the address location of the references, and equals, this method compares the content at of the references being compared. So at line 11 c string equals to a string, that is does c string and a string have the same address? Do they point to the same address? C string and a string do point to the same address, that is 100 as per our example, right? So therefore this evaluates to true and 1 dot equal is printed. Line 9 is printed. Line 10 c string dot equals a string. So whether the content of c string is the same as the content of a string, both content is u, right? So u equals u, right? So therefore this is also true. Line 12, this is also true. Line 12, if u equals a string, u is a string literal, and the content of this is equal to the content of a string, right, which is also u. So this also prints 3 equal. This evaluates to true and line 13 is printed. Line 14, b string equals a string. Yes, this is also true because the content of these two strings is u. So 4 dot equal is printed. This is also printed. This again at the compile time evaluates to string literal u. Now with string literal u equals to a string, we have a string literal here, right? So the address of this string literal is stored at the compile time, and this is also the same, which is address 100. So therefore when we're checking equals to the reference address of these string references, that is 100. So in this case this also evaluates to true and 5 equal to is printed. This section is the output, how it is printed. Okay, so this evaluates to true and yes, 5 values to true, and this is printed. Next, if b string equals to a string, b string and a string also point to the same address, so therefore 6 dot equals to is printed. This evaluates to true. Okay, and at line 20, b string equals to new string u. Now what happens here is when we do new string u, so this is a new object which is created at runtime. So let's say it is stored at address 110. So here at the runtime, a new string is stored at address 110, and let's say this is the new string that is created. Now we're checking if b string equals to new string. The address of b string is 100. The new string address that we've created, that is 110, and these are not pointing to the same address, right? The addresses are not the same. So therefore this is not printed. Else condition is executed and a dot not equal to is printed.